dogs, let's take a look at example 3. So again, we want to solve this quadratic inequality. I do want to take note that this time we have a lead negative. Now, I'm being asked to do this graphically, so I'm going to still make a graph. And you see me, I like to find interesting points. I think intercepts are interesting points. And I ultimately always want to find an x-intercept by letting y equal 0 or letting my function equal 0. So that means when is negative x squared minus 8x minus 12 equal to 0? You could factor, you could use the quadratic formula, you could complete a square to solve this. I'm going to go ahead and factor, but for me, I don't like when I have to factor with a lead negative. So what I'm going to do is I'm actually going to factor out the negative, because if I ultimately want to figure out where this is 0, I still need to figure out where x squared plus 8x plus 12 is 0, right? I could essentially divide both sides by -1 and just solve when is x squared plus 8x plus 12 equals 0. I'm going to factor this. So this is going to be x plus, what do we got, 6, x plus 2, right? Two things multiply to 12 but add up to 8. So I'm looking at -6 and -2. So I'll just keep in mind that I've got two x-intercepts at -6, 0, -2, 0. And I could have graphed this on my calculator and taken a look at that as well. And just so we have that for reference, let me clear out my last problem. Actually, I'll just add the negative in here, and then I'll change this to a subtraction symbol. When I hit zoom 6, we can see that I've got those x-intercepts at -6, -2. And my y-intercept is going to be down here at -12. I can't quite see it on my window. I could adjust my calculator window if I wanted to, but I don't really need to. And keep in mind, if you wanted to find the vertex on your graphing calculator, and if I just kind of estimate it, my vertex it's here. So what, -1, 2, 3, 4, 1, 2, 3, 4. It kind of looks like it's at -4, 4-ish. So I could do second trace. I could calculate that maximum by hitting 4. Let me get Blinky on the left side of my max. Okay, and then let me move them to the right and hit enter. And that sure enough is at -4, 4. I'll keep that in mind. I'm also going to do this algebraically just so we have it all there. But I've got my vertex. So let me go ahead, clear out of this. Let me go back to here. Let's find the y-intercept, and then we'll officially go find the vertex. So if I want the y-intercept, let's find f of 0, which is -0 squared minus 8 times 0 minus 12, which is ultimately just -12. So there's my y-intercept. If I wanted to find the vertex, we've got that formula for the x-coordinate, which is -b over 2a. Right? And then whatever x value I get for the vertex, I'm going to plug it back into this function and find the y value, keeping in mind that I kind of already know it, right? Spoiler alert, I should be getting a -4 when I crunch this in a moment, right? And then when I plug -4 into the original function, I should get a +4. But let's check it. Never hurts to check that our algebra matches what our calculator says. So my b value is -8, so I have negative of -8 over 2 times, okay, this case it's -1. So negative of -8 is +8. +8 over -2 is -4. So that x-coordinate is consistent with what I got in my calculator. Let's see if the y value, the corresponding y value is +4. So let's find f of -4. That would be a negative of -4 squared minus 8 times -4 minus 12. A lot of negatives in there, so I'm going to be careful. -4 squared, like without that PEMDAS, right? I'm going to do the parentheses. -4 squared is +16. +16 times -1 is -16. Right? And then we have -8 times -4, which is going to be +32. And then I have this -12. Well, -16 minus 12, that's -28. -28 plus 32 is going to be +4. That does check out with what our calculator had. So my vertex is -4, 4. And this will just help me graph. So I'm going to go graph this thing. Let me go ahead and make my little XY axes. And then we'll solve this inequality. All right, just thinking of the numbers, I've got a -6, a -2, a -12, and then 4s. I'm gonna scooch this a little high up just so I can graph down to that -12. All right, and then I'm gonna go on this side because most of my x coordinates for my important points are negative. Okay, so actually let me extend this y because I gotta go all the way down to -12. Okay, so what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'll put my my y-intercept there. I gotta go out 1, 2, 3, 4, 5, 6. So there's -6, and then I had another x-intercept at -2, and then my vertex was -4. Oh, all the way up here. So 1, 2, 3, 4, -4, 4. And again, because I've got that negative x squared, my lead coefficient is negative, I'm gonna have an upside down parabola. And we saw that in our graph, but I can finish this here like so. And let's see, on my last example, I did so terrible connecting these dots. Okay, so great, there's my graph. All right, now we've graphed the left side. Now let's take account for this inequality, right? What does it mean to be less than or equal to 0? So I want to figure out where is this graph below the x-axis, right? And where is it on the x-axis? All right, because when something's strictly less than 0, it means it's below. When it's equal to 0, it's on. All right, so let's go highlight this. I want below and I want on the x-axis. So I want this interval here, right? And I do want to include this this point. And I want that point because that's on the x-axis, and then I want to go below. All right, so if I remember my x coordinates, because when we write up these intervals, when it says write your solution in interval notation, we only care about the x coordinates. So this was what, -6 and -2. So as I move left to right along the x-axis, right, I'm below the x-axis here. So I start at -infinity, I end at -6. I put the bracket because I want to include when my graph was equal to 0, when it was on the x-axis, and my graph was on the x-axis when x was -6. And then I want to start back up again and go from 2 to infinity. All right, thanks so much everyone, bye.